Hello students, today we are going to discuss about some problems of your NCERT textbooks from chapter Force and Laws of Motion. Now let's see on the board. Here we discuss about the question number 6. Actually this question tells that a stone of mass 1 kg is thrown with velocity 20 meter per second across the frozen surface of a lake and comes to rest after traveling a distance of 50 meter. What is the force of friction between the stone and the ice? Here first of all, to solving the numerical, we should write all the things. So here the mass of stone is 1 kg and its initial velocity, that means is equal to 20 meter per second, and comes to rest, that means across the frozen surface of the lake and comes to rest, that means the final velocity is 0 meter per second by traveling a distance that is equal to 50 meter. Then here the question, what is the force of friction between the stone and the ice? Now first we can say in these questions we applied the equations of motion, and by these equations we calculate just the acceleration. After that we get force because we have the mass of the stone. So from equations of motion we have v square is equal to u square plus 2as, or 2as is equal to v square minus u square. Therefore a is equal to v square is 0 minus u square, that means 20 into 20 by 2 into s, that means 50, and we get the acceleration is equal to minus 4 meter per second square, minus 4 meter per second square. Now we have F is equal to mass into, so this is the resistive force. Resistive force is just a negative, so we can say mass 1 into minus 4, that means minus 4 Newton answer. Now just text. Now we discussed about the questions, that is question number 7 of your NCERT textbook. Now question number 7. Here 7 a very important question. Question 7. This question tells a 8,000 kg engine pulls a train of 5 wagons, each of 2,000 kg. Total mass of train is equal to, actually the train have 8,000 kg mass of engine and 5 wagons of 2, that means the total is equal to 18,000 kg. This is the total mass of, total mass of the train. And on the along the horizontal track, if the engine exert a force of 40,000 Newton, that means the force is equal to 40,000 Newton. This is the force by engine. This is the force by engine. And the track offer the friction is here, the frictional force is equal to 5,000 Newton. So we can say the net force is equal to force by engine minus frictional force, and we get 35,000 Newton. So if you want, here the question says to calculate the net accelerating force. If you want to get the net accelerating force, that means net accelerating force. So this net accelerating force is equal to net force. Actually we should net accelerate, this is that the net accelerating force is equal to 35,000 Newton. Now here the next question is the acceleration of the train. So the acceleration of the train is equal to the total net force by actual total mass of the train, and this is equal to 35,000 by 18,000, and we get this value is equal to 1.94 meter per second square. And the next is the force of the wagon 1 and 1 on wagon 2. So here we get the acceleration and take the mass of the wagon 2. That means the second wagon have a 3 more wagon inside it. So we calculate the net force on wagon 1 by wagon 2 by calculating these methods. Thank you.